This is called MAC flapping, and this is called loop, layer 2 loop, right? In the same way, when this PC will generate a broadcast message, OLF, and source MAC is, let's say, 0B. This switch will learn 0B MAC address on their receiving interface, 0/1 interface MAC address is 0B. After that, it will forward one copy from this interface and one copy from this interface. Let's say spanning tree is disabled, so both port is in forwarding state. Switch 2 will receive same broadcast message on two interface, on this interface as well as on this interface. So on both interface, first it will learn 0B MAC address on this port, after that it will learn 0 MAC address on this port. Again it will remove this entry, it will make new entry. Again after some time it will receive the same broadcast message on this port, and this broadcast message will be moving for lifetime, because this switch will forward broadcast message to this switch will learn MAC address on this port, after that it will forward it from this port. Switch 2 will learn MAC address on this port, then it will forward to this switch. This switch will learn MAC address on this port, after that it will forward from this port. So this packet, this frame will be moving for lifetime in around these three switch, around three switches. Yes or no? So this is called, guys, layer 2 loop. And to avoid this layer 2 loop, we come up with protocol called STP, spanning tree protocol. Okay, so in simple word, we can say a spanning tree is a protocol which is used to avoid layer 2 loop. In this scenario, if you want to see that how loop can form, simply you can disable a spanning tree protocol on all switches and you can generate a broadcast message. Okay, I am going to disable a spanning tree. Let's say on this switch I am going to say no spanning tree for VLAN 1. By default, CST is not running on switches, but first of all we are going to learn CST, common spanning tree protocol. So here PVST is running, means let's suppose we have 10 number of VLAN, so there will be 10 number of STP instances. So I am going to say no spanning tree for VLAN 1. I have disabled a spanning tree protocol for VLAN 1, and now if you will run command show a spanning tree here, you can see no spanning tree instances exist. In the same way, I am going to disable a spanning tree on switch number 2 also. Say no spanning tree for VLAN 1, because by default only VLAN 1 is exist on switches. So VLAN 1. And on this switch also I am going to disable a spanning tree protocol. No spanning tree for VLAN 1. I have disabled a spanning tree protocol on all switches, and you can see link is blinking. Are you able to see? Link between switches is started blinking because of layer 2 messages that switch by default forward to their neighbor. Okay, and all link is in forwarding state. And here if I will configure one IP address, then this machine will generate what? One broadcast message, that is gracious ARP. And because of gracious ARP also, you can see that gracious ARP packet is also moving between switches. If you will check MAC address table, so MAC address table, so you can see MAC address table is flapping. MAC address, what is the MAC address of PC? 1. In the last it's BA. BA 0/2, 0/1, and if you will check now 0/1, again you will check 0/2, again you can see 0/1. It is learning this MAC address on both interface quickly, right? So this is MAC flapping. MAC address is flapping, this MAC address is flapping between 0/1 and 0/2. Fine. Is it clear?
Yes.
Okay, Suresh.
Yes, sir. Clear, sir.
Good. Now, in a spanning tree protocol, guys, we have to understand how. First, we have to understand how a spanning tree protocol avoid loop. So, anyone can explain how a spanning tree is going to avoid the loop? Because here, if I will enable a spanning tree protocol, then problem will resolve. A spanning tree for VLAN 1, you can see a spanning tree for VLAN 1. Now one port will be in blocking state. You can see this port is in blocking state. So now my logical topology is like this. This link is not used for data forwarding. If this PC want to communicate with this PC, they will communicate via switch 1. So how a spanning tree is avoiding loop, guys? Anyone?
By electing the root port, designated port, and blocking port, sir.
Yeah. First of all, it will elect one switch as a root bridge switch. One switch as root bridge switch. Okay. So in this domain, we have three switches. Out of these three switches, one switch is going to become root bridge. To avoid layer 2 loop, switches are going to perform root bridge election. In root bridge election, one switch will be winner. Now question is, one switch will be the winner.
Which is having the lowest MAC address.
Lowest MAC address. No, 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 no.
Lowest bridge ID.
Yeah,
Bridge ID.
lowest bridge ID. Switch which will have lowest, or you can say best. Best means lowest bridge ID. Now question is, what is bridge ID?
Bridge ID is a combination of priority number plus VLAN.
Plus VLAN.
VLAN. VLAN ID.
No,
Yes.
sir.
VLAN ID,
MAC
that is
address.
in PVST, MAC address. Very good. This is a combination of two things, priority plus base MAC address of switch. Base MAC address of switch. So all switch will have one bridge ID. Let's say MAC address of this switch is 0A, MAC address of this switch is 0B, and MAC address of this switch is 0C. This is the base MAC address of all switches. And by default, priority on switches is 32768.
68.
It is by default priority, we can change it. So what will be the bridge ID of switch 1? 32768 plus 0A is the bridge ID of switch 1. What will be the bridge ID of switch 2? 32768 plus 0 B. And what will be the bridge ID of switch 3? 32768 plus 0 C. Now you tell me which switch have lowest bridge ID, because priority is by
0A.
default same. Switch
0A.
0A.
Switch
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 1,
1.
sir. 0.
Priority is by default 0A. So here root bridge election is happening on the basis of lower
MAC
base MAC address. So switch 1 will win the election. Switch 1 will become root bridge. This is the first step. Right? First step is done. One switch will become root bridge. Now in my scenario, switch 1 is my root bridge. After that, here a spanning tree protocol is going to perform port election of switches. So how many types of port role, guys, in a spanning tree protocol? How many role of ports
3,
are
sir.
there? 3. Yeah,
Yes,
may I
sir.
know the name? First one is
Root port.
okay, root port.
Designated
Designated
port.
port.
Designated port.
Blocking.
Designated port, not blocking. Alternate port. Alternate port. There are three role of ports in a spanning tree protocol. If I will talk about the root port, so guys, status of root port will be always forwarding. Designated port will be also in forwarding state, but alternate port will be always in blocking state. This port will be always in blocking state. So if a port role is alternate, then a status of that port will be blocking. If port role is designated port DP, then forwarding state will be forwarding, and root port will also have forwarding state. Now question is, which port is going to become designated port, which port is going to become root port, and what is root port, what is designated port, and what is alternate port. So what is designated port? First question. What is designated port?
Port having the less path cost towards root bridge.
No, is not the designated port, brother. Designated port is the port which will transmit best BPDU. Now question is, what is BPDU? So BPDU is a type of message of a spanning tree protocol. Wait. If I will talk about the message of a spanning tree protocol, so we have only one message in a spanning tree protocol, that is, what is happening? Okay, leave. If I will talk about message of STP, so we have only one message in STP, that is BPDU. BPDU stands for,
Bridge protocol data unit.
yes, Breeze Protocol Data Unit. Breeze Protocol Data Unit. This is message of STP, and there are two types of BPDU. One is configuration BPDU and one is TCN BPDU. We will understand that. Okay. First understand, okay, this is the BPDU is the message of a spanning tree protocol. Now my concern is, what is DP? What is designated port? So designated port is the port port ports which transmit superior, or we can say best BPDU. Best BPDU. Now what is best BPDU? What is the meaning of best BPDU? Yes, or superior BPDU. Guys, in this scenario, you know, when we will enable a spanning tree protocol, first all switch will think that I am root bridge. Yes or no? Like DR and BDR election. First of all, in the OSPF network, in the broadcast network type of OSPF, all routers declare their self as DR. All are thinking that I am DR, but when router will receive message with higher router ID with their neighbor, then it will came to know that no, I am not DR. Yes or no? In the same way, here between these three switches, all switch will think that I am root bridge, and all switches is going to share their BPDU message. All switches is going to share their BPDU message to their neighbor switch, like this. BPDU message. BPDU is nothing but like hello message of OSPF or EIGRP. After every 2 second root bridge switch, first of all switches will send BPDU. After that, once root bridge election will done, then only root bridge switch is going to send BPDU after every 2 second. After every 2 second. But initially all switches will send BPDU. So when switch 1 will share their BPDU, so in the BPDU message carry bridge ID. So here bridge ID is 0A plus 32768 plus 0A is the bridge ID of this switch. 32768 plus 0B is the bridge ID of this switch, and 32768 plus 0C is the bridge ID of this switch. Yes or no? Now all switches will send BPDU message to their neighbor, because all switches are thinking that I am root bridge. Okay, but when switch 2 will receive BPDU message from switch 1, it will stop declaring their self as root bridge. It will stop sending BPDU message. Once switch 2 and switch 3 will receive message BPDU message from switch 1, it will stop sending BPDU message. Why? Because if you will compare the BPDU of all switches, switch 1 have best BPDU, because in the BPDU carry root bridge ID, and in the BPDU of switch 1 there is lowest bridge ID as compared to switch 2 and switch 3. So which switch is sending superior BPDU?
Road bridge, sir.
Yeah,
Switch one.
switch 1 have superior BPDU. So switch 1 will send BPDU from this port as well as from this port BPDU. Both BPDU is same. In BPDU, root bridge ID will be 32768 plus 0A. In this BPDU also 32768 plus 0A. There will be two more important information: root bridge ID and sender bridge ID. Root bridge ID and sender bridge ID. Soon we are going to discuss that also, what will be the content inside the root bridge ID, inside the BPDU message. But for now, switch 1 have superior BPDU, because in the BPDU of switch 1, bridge ID is best. So this two port will become DP, because these two ports are transmitting superior BPDU. And this port will receive superior BPDU. This port will receive superior BPDU, because when switch 2 switch 3 will receive BPDU from switch 1, it will forward that BPDU to switch number 2 also. So switch 2 is receiving BPDU on two interface, on this interface and on this interface, but it receiving superior BPDU on which interface? It is receiving superior BPDU on this interface, because in this BPDU bridge ID is 32768 plus 0A and sender bridge ID is 32768 plus 0A. But in this BPDU ID which switch 1 is receiving on this port, root bridge ID is still same 32768 plus 0A, but sender bridge ID is 32768 plus 0C. 32768 plus 0C. That means I am receiving, switch 2 is receiving superior BPDU on this port. So this port will become RP. In the same way, switch 3 is also receiving superior BPDU over here. So this port will become RP. Now on this particular segment, always keep in mind, on a single segment there can be only one DP, and on a single switch there can be only one RP. There can be not more than one RP on a single switch, and there can be not more than one DP on a single link, on a single segment. So in this segment we need to actually identify that which switch is sending superior BPDU. This port is sending superior BPDU, or this port is sending superior BPDU on this link. So see, switch 2 is sending BPDU. In that BPDU, root bridge ID is 32768 plus 0A, and sender bridge ID is 32768 plus 0B. Here when switch 3 is sending BPDU on this link, root bridge ID is 32768 plus 0A and sender bridge ID is 32768 plus 0B. Now you tell me which switch is sending superior BPDU on this segment.
Switch B, sir.
Yeah, switch 2. So this port will become what? DP. And as you know, on this switch we have already one RP, and on this single segment there can be not more than one DP. So this port will become what? Alternate port. Fine. Is it clear
Yes, sir.
to all? Nirav?
Yes, sir.
Clear?
Yes, yes.
Very good. Anyone have
And
any
sir,
confusion? Yes.
in some videos they say, for example, on switch two, so they show which will be the root port, correct? So
Correct.
they explain in this way that since switch 2 has two ports F0 02 and 03, correct? So when they will check the path towards this particular root switch.
Path cost.
Yes, path cost.
Path
So
cost is third criteria. When root bridge ID and sender bridge ID, these two things will tie. Then it is going to
okay.
check next thing, that is root path cost. But here root path cost is not required, na? Without root path cost, we can elect the port role of a spanning tree protocol. Yes or no? Now, first let's discuss content of BPDU. Then it will be very easy to you to understand this thing. Let me talk about the content inside the BPDU. Contents of BPDUs. Okay, first information will be, guys, protocol ID. We are not going to discuss those things like protocol ID. There will be information of version. After that there will be information of type, like which type of BPDU it is. As I told you, there are two types of BPDU: configuration BPDU and TCN BPDU. So that information will be also there in BPDU. But I am going to talk about the important thing, important information. Important information will be root bridge ID. Root bridge ID. Second information will be their sender bridge ID, or we can say designated bridge ID. Sender bridge ID. After that there will be information of cost. Cost. Which type of cost it is? This is root path cost. Always keep in mind, whenever root bridge switch will generate BPDU, it will generate BPDU with cost 0, because this is the cost to reach root bridge. Cost to reach root bridge means cost from root bridge to root bridge will be always 0, and cost to reach root bridge from any other switch will something, right? So root bridge will generate BPDU with cost 0, and receiving switch will add cost of their interface. Cost of their interface. Okay, so there will be cost information. After that, fourth information, there will be many more information like message time, forward delay time, messages, hello time. There will be information about designated port ID. Designated port ID is also important. Port ID. After that, there will be information about protocol, as I told you, version, type, those things. Flag information will be there. Flag is also important. There are how many flag are there in BPDU? there are 8 flags. 8 flag. Out of 8 flags, we are using only 2 flags. 8 bits are there for flag, and seventh means last bit is TC bit used for TCN BPDO. Topology change, we will discuss topology change notification, that time you will understand this bit also. And 0 bit means first bit is used for acknowledgement, TC ACK. TC ACK. Okay, so these are the important information of BPDO. BPDO will carry these information. Getting my point? Clear, guys? So let's say if I have 3 switch 1, or let me design here, switch 1, switch 2, and switch 3. Let's say this switch have MAC address 0A. This is my switch 1, and MAC address of this switch is 0A. This is switch 2, and MAC address of this switch is 0B. This is switch 3, and MAC address of this switch is 0C. Okay, all switches are connected like this. Let's say this is 0/0 or 0/1. This is also 0/1. This is 0/2, and let's say this is 0/3. So in this scenario, which switch will become root bridge? What will be the bridge ID of switch 1? 32768
768
plus 0A. Bridge ID of switch 1. Bridge ID of switch 2 will be 0 B here, and bridge ID of switch 3 will be 0C over here. Yes or no? So which switch have lowest bridge ID? Switch 1. Switch 1 have lowest bridge ID, so switch 1 will become what? Root bridge. So root bridge switch will generate what? Configuration BPDU after every 2 seconds. In their configuration BPDU, there will be some information, as I told you, like root bridge ID. Root bridge ID will be what? 32768 plus 0 A. After that, there will be information of cost. Second information will be cost. That will be, as I told you, 0. Cost, root bridge always generate cost 0 BPDO. Cost will be 0. Third information will be sender bridge ID, or we can say designated bridge ID. Sender bridge ID. What will be the sender bridge ID? 32768 plus 0 A. Same? Same, yes or no? After that, there will be designated port ID. Sender port ID. Sender port ID. We should discuss port ID as well. Sender port ID, or in book you will say designated port ID. Designated port ID. Designated port ID will be what? Port ID of exit interface. You know, STP port ID is again combination of two things. Spanning tree port ID is combination of two things. Port priority STP port ID is combination of two things. STP priority,
And port
port
number.
priority plus port ID, interface ID. By default priority is 128 and interface is F0/1, 0/1, yes or no? Interface is
Yes.
F0/1. So STP port ID will become what? 128 plus interface ID 1 means 129. We will not write like 129, it will be 128.1. This is the port ID of this port. So there will be information of port ID, sender port ID. So sender port ID will be 128.1. This information switch 1 will send to switch 2. Switch 2. This is the BPDU which switch 1 have generated. It will forward this BPDU to switch 2. Now when switch 2 will receive it, switch 2 will add what it will add? Cost. Receiving interface cost. Receiving interface cost will become what? By default, cost of interface is fast Ethernet link is 19, as we already discussed this. Cost is 19 by default for fast Ethernet 0/ for fast Ethernet link. So cost will become 90 over here, 19 over here, and sender base ID will be what? Sender base ID will be also changed. It will be 32768 plus 0B. Sender base ID will become 32768 plus 0B. And designated port ID. Designated port ID will be also what? 128.2 sending port ID. It is going to send this BPDU from which interface? 2/0. So this designated port ID will be also 128.2. After that, switch 2 is going to forward this BPDU to switch 3. So switch 2, when switch 2 will receive BPDU from switch 1, it is not going to forward same BPDU as it is BPDU to their neighbor switch. First it will modify it. It will change sender sender base ID, cost and designated port. After that it will forward to switch 3. Let's say switch 3 have one neighbor. So it will share this BPDU to their neighbor also. Yes or no? So when it will share to their neighbor, what will be the cost, guys, over here? Cost will become what? 19 plus receiving interface cost, 19. Total cost will be 38. Total cost will become 38 over here. Means cost to reach root bridge from this route is, from this switch 3 is 38. Cost to reach root bridge is 38. And after that it will change sender base ID. Sender base ID will be become 32768 plus 0C over here. Zero C, and then maybe it will forward to their neighbor. This is the BPDU on switch number 3. Right now, which switch, this port is transmitting superior BPDU, so this port will become DP. This port is receiving superior BPDU, this port will become RP. In the same way, this port will become DP because this port is transmitting superior BPDU, and this port will become RP. Is it clear? Till here, if any doubt, please ask me, guys, because now we are going to understand the port election in big topology. Is it clear? Any doubt till here to understand anything? STP port is combination of two things, port priority plus interface ID. By default port priority is 128. By default cost of fast Ethernet link is 19, and root bridge generate zero cost BPDU, and switches will add their receiving interface cost in BPDU. Cost is nothing but cost to reach root bridge. Fine. Done. Okay. Let me tell you that I have one switch over here. Switch. Let's say this is switch 3, which we had discussed now. Switch 3. Now this switch 3 is receiving BPDU from two side. Let's say it is receiving BPDU from two side. Two switch is giving BPDU to this switch. So switch 3 will identify I am receiving superior BPDU on which port. Let's say it is receiving BPDU on 0/1 and 0/2. So to identify superior BPDU, first of all, switch is going to check what? Root bridge ID. It is going to check root bridge ID. That in which BPDU root bridge ID is lower. Root bridge ID. Let's say root bridge ID. Let's say in both BPDU root bridge ID is 32768 plus 0 A, here also and here also 32768 plus 0 A. So root bridge ID is same. Root bridge ID is same on both link. Then the next thing that switch is going to check is cost. What cost is coming in BPDU? So let's say cost value is also what? 0. 0 here and 0 here. Means root bridge switch is sending BPDU. So cost on both link is 0. So if cost will also tie, first thing it will check this root bridge ID, lower root bridge ID. After that it will check cost. If cost will also tie, then it is going to check what? Lower sender bridge ID. Sender bridge ID. And can sender bridge ID same on two interface? Yes, it can be same, yes or no, because let's say I have a topology like this, switch 1 and switch 2, and we have two link. So switch 2 will receive BPDU on these two interfaces. In that BPDU sender root bridge ID will be same, cost will be same 0 0, then sender bridge ID will be also same, yes or no. If sender bridge ID is
Port
also
ID.
same, then it is going to check what?
Port ID.
Which port ID?
Lower port ID, sir, it will check out of the two. The sender's port ID.
Sender port ID or receiving port ID? Then it is going to check lower sender port ID. Sender port ID, because that will be the information inside the
Yes.
BPDU, yes or no, sender port ID. And if sender port ID will be also tie, how it can be possible? Yes, it can be possible. Let's say this switch 1 is connected with one hub, and hub is connected with two link, and then we have switch 2, yes or no. In this scenario sender port ID will be also same, yes or no. Getting
Yes.
my point? So if sender port ID is also same, then it is going to check what? Lower receiving port ID. Port ID. Is it clear to all? Is it clear? If it is clear, then I am going to ask you guys question now. May I ask? Okay, then fine. Let me open one topology. I'm going to close this packet tracer file because I'm not going to use anymore. Here I have one topology in front of you. You can see the MAC addresses of all switch, right? Just you tell me which switch will become first root bridge.
Switch 1.
Switch 1, this switch is root bridge. So all port of this switch will become what? DP, 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 DP and DP. Yes or no?
Yes.
Now on switch number 2, this port 0/1 will become what?
RP, sir. Root port.
No, wrong. 0/1. I'm asking you 0/1 port. See brother, it is receiving BPDU on both port. First it will check what? Root bridge ID. Root bridge ID is same in both
Same.
BPDU. Then it is going to check sender bridge ID. Sender bridge ID is also
Same.
same in both BPDU. Then it is going to check.
Port ID.
Sorry, before that it will
Port.
check cost. So cost value will be also same. Then it will
Same.
check sender bridge ID. Sender bridge ID will tie. Then it will check what? Sender
Port. Sender port ID.
port ID. So sender port ID in this BPDU is 128.1
8.1
and in this
and
BPDU it is
128.0.
128.0. So it is receiving superior BPDU on this port. Yes or no?
Yes, sir.
Yes, sir.
So this port will become what then? This port
So that
0
port will
slash
become
1 alternate
Yes, sir.
alternate and this port will become RP.
Root port.
Now we have one RP on switch number 2. So tell me this port will become what then? Will
disable
this
or
port become DP?
Yes, sir. DP.
How? How this port is DP?
Because that will
You know,
send a
best way for STP port election is first of all on all switches you need to find RP. So okay, here we have find the RP on switch number 2. On switch number 3, tell me which port will be RP.
E0.
E0 by 0, this port
Yes.
RP. On switch number 4,
E02.
no, 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 no. It is
E00, sir.
when it will receive BPDU
Sorry.
over here, sender bridge ID will be and cost will be
No, no.
also, here cost will be
E
19, here cost will be
E11.
0.
Yes, yes. E11.
On
Root
the
port.
basis of what? Cost. Yes or
Yes.
no?
Yes, yes.
This port will become RP. Okay. On all switches we find the RP. Now next step is on every
Designated.
switches you need to find DP. So on switch number 2, see on this segment, actually we will find DP on segment. On this segment, both switches sending BPDU. Now question is which switch is sending? Superior BPDU. So which you tell me now which switch is sending superior BPDU? A B B C C 00300 and here 2000. Sender bridge ID of switch 2 is lower.
Switch 2. Switch 2 is
So this port will become DP. Now
DP.
here we have already RP. That means this port cannot become RP and on single segment there can be not more than 2 RP. So this port will be alternate. Yes. Now let me talk about this segment. On this segment, which port will become DP? This switch is also sending BPDU. This switch is also sending BPDU. First it will check root bridge ID. Root bridge ID is same in both. It will check cost. Cost is 19 in both BPDU. Then it will check what? Sender bridge
Sender
ID.
bridge ID.
So sender bridge ID of switch 2 is lower than switch 4. So this port will become what? DP and this port will be blocked. Am I right?
Yes.
On this link, On this link also, this port will become DP and this port will become alternate. Let me talk about switch 3. This port will become what? 0/1. RP is already there, right? And here DP is already there. That means definitely this port is
Block.
blocked, alternate. Okay, let me talk about these two link between switch 3 and switch 4. Which ports will become DP? Switch 3 ports or switch 4 ports? Here when it is transmitting, cost is 19. Here also when switch 4 is transmitting BPDU, cost is 19. Cost and root bridge ID is same. Then it is going to check third thing, that is sender bridge ID.
Left.
So switch 3 have lower sender bridge ID. So these two port will become what? DP, DP, and this two port will become what? Alternate. Yes or no? Is it clear to everyone? Or still, if anyone have problem, let me know. Clear?
Sir, can you repeat it once again, sir? From DP.
Okay.
RP is okay, sir. RP is clear. From
RP is
decimal.
clear. First of all,
Yeah.
let me verify it. Okay. Then I will repeat it. So, a
Okay.
spanning tree. Okay. So you can see all ports of switch 1 is designated port. DP. Fine. Let me take you to switch 2. Enable. So, a spanning tree. You can see 0/0 is RP. 0/0 is RP. And 0/1 is alternate, and rest all put 0/2, 0/3 and 1/1 is DP. Fine. Okay, Nirav. We are
Yes, sir.
verifying that our election is correct or not. Now let me take you to switch 3. So, spanning tree. 0/0 is root port. Fine. 0/1 is alternate port. Fine. 0/1, 3 and 1/0 is the designated port, and 1/1 is the alternate port. The link between switch 2 and switch 3 is the alternate, and these two ports is designated port, and the port where user is connected is also designated port. Okay, because from this link it is sending superior BPDU. It is switch is not receiving any BPDU on this link. So this port will be always DP. Now last switch is switch 4. So switch 4 also we can verify over here. So spanning tree. 0/0 is the alternate, 0/1 is the alternate, 0/2 is the alternate, 0/3 is the alternate, and 1/0 is the designated port. 1/0. Switch 4 have one designated port. Okay, that is this port, LAN connected, LAN user connected port, and E1/1 is the root port. Fine. We have verified everything is correct. Okay, I am going to explain one more time if anyone have confusion. Let me take here, and here I am going to design one topology, and this time my topology is switch 1. I am going to use two link between switches as well. Switch 1, switch 2, switch 3 and switch 4. Switch 1 MAC address is 0A. Switch 2 MAC address is 0B. Switch 3 MAC address is 0C, and switch 4 MAC address is 0D. Let me connect these switches. I have two link here. Here also I have two link. Here also I have two link. Here also I have two link, and between switches as well I have two number of link. This topology is little different from the previous. Okay, is topology clear? Now let's say this link is 0/1. Both side I'm using 0/1 port to connect switch 1 and switch 2. This is 0/2 interface. This is 0/3. This is 0/4, and this is 0/5. This is 0/6. This is 0/7. This is 0/8, and this is, you can say, 0/9, 0/10, 0/11, and 0/12. First of all, which switch will become root bridge? Yes. Which switch will become root bridge? First of all, tell me.
Switch 1, sir. Zero
Switch
eight.
1?
Yes.
Very good. This switch is your root bridge. So as you know, all ports of root bridge switch will become what?
Designated
DP.
ports.
DP, because it will send superior BPDU. This port will also DP. This is also DP port. This is also DP port. This is also DP port, and this is also your DP port. Okay, Suresh, till here clear? Now tell me, on every switches which port will become RP? You tell me. On switch number 2, which port will be RP?
So
It is
0 1, sir.
receiving BPDU on all ports. It is receiving BPDU on 0/0, also 2, 7, 8, 9, 10. On all ports it is receiving BPDU. But on which port it is receiving superior BPDU?
0 1s.
0/1, because here cost is 0, and on the basis of what it will elect that this port is root port. First it will check it is receiving BPD over here also, here also, here also, here also, here also, and here also. But in these BPDU, cost is not 0. Cost is not 0 in these BPDU, but cost is 0 in these two port BPDU only. So there is compare of sender base ID between these two BPDU. After that, there is comparison of sender port ID between these two BPDU. And on the basis of sender port ID, this port will become RP. Yes? Yes or no? On switch number 3, which port will become RP? Switch number 3.
3.
0/3. Very
Yes.
good. This port will be the RP. On switch number 4.
Sir, two ports naming is left.
0/5, 0/6.
Okay. Same. Oh, 05, 05.
0/5. This port will become RP. Clear, Suresh? Mohan,
Yes, sir.
this port will be RP. So on all switches we find the RP port. Now next step is on every segment we are going to find DP or block. So this port will be DP or blocked. DP is already there. RP on this switch is already available. So this port can't be DP or this port can't be RP. So we have only one option, that is alternate. So this port will be alternate. This port will be also what? DP or alternate, because this port can be DP or it can be alternate because RP is already available. So
Uh,
to identify this port is DP or alternate, what you will check? DP port means sending BPDU. Which switch is sending superior BPDU on this
The
segment?
7 number port DP.
7 number port, because switch 2 is sending superior BPDU on this link. Getting my point, Mohan?
yes, sir.
Actually, switch 2
Because
is
of
also
lower.
sending BPDU over here, and this switch is also sending BPDU. But when switch 2 is sending superior BPDU, it have lower bridge ID, sender bridge ID. Yes or no? So
Yes,
because
sir.
of that, 0/7 will be DP,
DB. Yeah.
right? In the same way, 0/8 will be DP. Yes or no?
Yes, sir.
In the same way, 0/9 will be DP because switch 4 have. And why you are comparing sender base ID? Because when switch 4 will transmit the BPDU on this link, then cost will be
38.
okay.
Cost,
Cost will be 19 in both scenario. Sorry,
cost will be same, sir.
cost will be same. So it will be, election will happen on the basis of sender base ID only.
And
So switch 2 port will become DP. This port DP and this port will be DP. Yes or no? After that, on switch number 3, you can see on this link DP is already available, so this port will become alternate, right? This port on this link also DP is already available and RP is already available in this switch, so this port will become alternate. Am I right? And this port will become what? DP is already available, RP is already here on this switch, so this port will be also alternate.
alternate.
Fine. Now on switch number 4, this link, RP is already available and DP is already available on this link. So this port will become
Alternate.
alternate. This port will become also alternate. Right? This port will also become alternate. And between switch 2, switch 3 and switch 4, we have two link. Now which switch is sending superior BPDU?
Switch 3, sir.
Switch 3.
Switch 3. So this port will become DP.
Yes.
This port will become DP. This
Yes.
port will become alternate. This port will become alternate. So guys, what is my logical topology here? If you need to design logical topology, then how you will design logical topology? You have 4 switch, switch 1, switch 2, switch 3 and switch 4. You need to design logical topology, loop free topology. This is switch 1, this is switch 2, this is switch 3, and you have to identify that loop can form in this topology or not. So between switch 1 and switch 2, how many link is there in forwarding state? Only one, right? 0/1. After that, between switch 2 and switch 3, we don't have any link. Yes or no? You can see there is no any link in forwarding state between switch 2 and switch 4. Yes or no? Between switch 1 and switch 4, yes, there is one link, that is 0/5. So here we have one link. 0 slash 5. Between switch 1 and switch 3, yes, I have one link 0 slash 3. Yes or no?
Yes.
Yes or no, guys?
Yes,
Yes.
sir.
This is my logical topology. Is there any more link in forwarding state?
No.
No.
So can loop form over here in this topology? No. This is logical topology, loop free topology. This is 0 slash 1. So whenever you are electing root port or STP ports, after your election, you should design loop free topology and you should identify it. That loop can form in my topology or not. This is 0 slash 5 and this is 0 slash 3. Now, interviewer can ask you that in this scenario, I want to design not this loop free topology. I want to design this loop free topology. Right? Means if here I have one computer and here I have one computer. By the way, this is PC1, this is PC2. PC1 and PC2 will communicate via switch number 1. Yes or no? But if interview will ask you that directly I want that switch 1 should communicate directly via switch number 4, then how you will manipulate the spanning tree path election? Or they can ask you that please design this loop free topology. This means PC1 and PC2 should be able to communicate with each other via switch number 2. So can you design this topology? Can anyone design this topology? Where I need
Yes,
to
sir.
change?
Sir, we'll make that switch 4 as a root bit, sir. Here.
Okay, if your switch
But,
4 is root breeze,
yeah.
if switch 4 is root breeze, then what will happen? This link will be used 0 slash 5. Am I right?
Yes, sir.
And between switch 4 and switch 3, we will have one link that is 0 slash 11 because switch 4 is my root breeze. And between switch 2 and switch 4, we will have one link that is 0 slash 9. This is my loop free topology. Here is the PC. My concern is PC1 want to communicate with PC communicate with each other via switch number 2, but it is communicating via switch number 1 to switch number 4. So you will configure this switch as root bridge, but the good thing, you are not allowed to change root bridge because root bridge switch is the switch with good hardware. We cannot change the root bridge. Brother, if I don't want to make this port as a RP, I want that this port should be RP. I can increase port priority over here, yes or no? Because it is receiving BPDU over here also and BPDU over here also. First it will check root bridge ID. Root bridge ID in both BPDU is same. Second thing that it is going to check is cost. Here if I will set cost 100, then what will happen? Now this port will become RP, this port. Yes or no? Getting my point? Hello? See in my scenario what I am saying. This is my scenario. In this scenario, switch 4, switch 2 have which port is blocked and which port is RP. So a spanning tree. RP is RP 0 slash 0. 0 slash 0 means there is one link between switch 1 and switch 2. If I want to, my logical topology is this one by default. Switch 1, 2, 3 and 4. Here I have one link and on other switches as well I am going to check on switch number 2, not switch 2, on switch number 3. So a spanning tree. RP is 0 slash 0. 0 slash 0 means there is one link over here, and switch 4 enable. So spanning tree, RP, where is RP? 1 slash 1 is the RP. Means that means, oh my, 1 second guys. There is one link between switch 1 and switch 4. This is right. This is switch 1, switch 2, switch 3, and switch 4. Here I have one PC. Here I have one PC. PC1 and PC2. When PC1 will ping to PC2, traffic will go via switch number 3. But I want that traffic should go via router number 2. I want to use this link. This link. So this port should be RP. This port should be RP. So what I can do, if I will increase priority on this link 0 slash 0 on this port, then what will happen? This port will become RP. So I am going to increase priority on these two port, on both port. Automatically this port will become what? RP, and this link will block, and this link will come in forwarding state. Getting my point? Getting my point, guys? So on switch number 2, what I will say, interface range F 0 slash not F, E 0 slash 0 and E 0 slash 1. A spanning tree port priority. Port priority. What priority I want to set over here? More than 19. Because when it is receiving BPDU on this port, BPDU, the cost is 19. So here I am going to set cost more than 19 on this two link. Okay. So here port priority, and this is different thing. This is port priority. I need to change cost. So a spanning tree cost, and here I am going to set cost, let's say 100. And now if you will check, so a spanning tree, now you can see RP is still 0 slash 0 is the RP, cost is 100. Okay, this is not fast Ethernet link, this is Ethernet link. So by default cost on Ethernet link is 100. I am going to set 200 over here. Interface range E 0 slash 0 and E 0 slash 1. A spanning tree cost 200. And so a spanning tree. Now RP is, wait for 30 seconds. After 30 seconds you will see RP, this port is in listening state now 0 slash 0, and cost over here is 200. Cost over here is 200. So RP port, this 0 E1 slash 1 will become RP now. E1 slash 1, where it is E1 slash 1, this port is alternate. Still this port is in listening, learning state. Forwarding. Why E0 slash 0 is still a root port? E1 slash 1, I am
Sir,
going
cost
to
cost
decrease
will be same now, sir. Ethernet 1/1 and
cost
as it will cost will be same, sir. It will reach via switch
100.
3 no, sir.
Oh,
Plus
cost
100.
will be same, plus 100. Yes, very good. Interface range E 0 slash 0 and E 0 slash 1. a spanning tree cost 205. No, it's fine. So a spanning tree. I think this time it's fine. You can see 1/1 is the RP. Now I have changed the topology. I have changed the logical topology. Yes or no? So actually in real time also when we need to manipulate the path, we are using cost value. Okay. We are not changing root bridge directly. Okay, Mohan.
Yes, sir.
Any doubt till here to anybody?